Imagine for a moment two friends, Alex and Ben. They venture into a new experience together, maybe trying out a new video game, or having their first glass of wine at a party. For Alex, this experience is enjoyable, a pleasant little diversion, but honestly, it's ultimately forgettable. He can take it or leave it. The next day, his universe just continues on its predictable, stable orbit, totally unaffected by the brief gravitational pull of this new activity. But for Ben, the story unfolds quite differently. That same experience latches onto him with an unexpected force. The pleasure he feels isn't just pleasant, it's profound, almost like a supernova of sensation that outshines everything else. The next day, he finds his thoughts drifting back to it, a constant, gentle pull, kind of like a moon orbiting a planet. He craves a return to that feeling, and the desire only grows stronger and more insistent over time. This isn't a conscious choice, but a deep, almost primal urge. Why does the same star shine so differently for two people standing side by side, looking up at the same night sky? This divergence is, honestly, the central mystery of addiction. It highlights a fundamental truth about our human experience. We are not all built the same. Our internal universes, the complex galaxies of our brains, are wired in uniquely personal ways. The answer to why Ben feels this powerful pull while Alex does not lies deep within us, written in the code of our genes, sculpted by our life experiences, and orchestrated by the intricate dance of chemicals within our skulls. So, what exactly is addiction? At its heart, addiction is a chronic, relapsing condition, characterized by a compulsive drive to seek and use a substance or engage in a behavior, even when you know the harmful consequences. Think of it as a powerful gravitational force that's captured a celestial body, your decision-making ability, and pulled it into a new, often destructive orbit. This force overrides your rational mind, the part of you that can weigh long-term consequences against short-term rewards. It creates a cosmic tug-of-war inside your head, where the primal urge for that immediate reward almost always wins. We often associate addiction with illicit drugs or alcohol, and for good reason. These substances can exert a powerful influence on our brain chemistry, but the realm of addiction is actually far vaster than that. It can extend to behaviors that, on the surface, seem totally harmless. People can become addicted to gambling, endless social media scrolling, video games, shopping. The object of addiction can change, but the underlying mechanism in the brain stays remarkably consistent. It's a pattern of craving, compulsion, consequence that can disrupt every aspect of a person's life, from their health to their relationships. Understanding addiction is critically important for us as a species. It affects millions of people across the planet, from every walk of life, and its ripple effects touch families, communities, entire societies. It's a public health crisis that fuels other problems, crime, economic instability. When we fail to understand the science behind it, we risk treating it with stigma and shame, which just pushes those who are struggling further into the shadows. By illuminating the biological factors at play and the environmental factors at play, we can foster a universe of empathy and develop more effective pathways to support and recovery. Let's be clear. Addiction is not a choice in the way we choose what to eat for breakfast. While the first use of a substance might be a choice, the changes that follow in the brain can hijack that very ability to choose. The brain becomes rewired, its priorities reordered, until the addiction itself sits at the command center, directing operations. It is a disease of the brain, as real and as physical as heart disease, diabetes. Our quest is to understand how this hijacking happens and why some brains are more susceptible to the takeover than others. To understand addiction, we have to journey deep inside the human brain, to a set of ancient structures known as the reward system. This system isn't a flaw. It's actually a feature, essential to our survival. It evolved over millions of years to reward behaviors that help us live and pass on our genes. Eating, drinking water, connecting with others. When you do something your brain perceives as beneficial for survival, the reward system releases a powerful chemical messenger called dopamine. Think of dopamine as a starburst of pleasure, a little "good job" signal from your brain. Dopamine does more than make you feel good. It teaches your brain to remember what you did to get that reward, and it motivates you to do it again. It forges a simple equation: action equals pleasure. That's why a delicious meal tastes satisfying and why time with loved ones feels fulfilling. Your brain is basically saying, "That was great. Let's repeat it." This dopamine-driven learning is how we form habits and navigate our world. But addictive substances and behaviors hijack this survival mechanism. They make the brain release floods of dopamine, far more than natural rewards. For example, cocaine can cause a dopamine surge 2 to 10 times higher than natural rewards. That surge creates overwhelming euphoria, signaling to your brain, "This is the most important thing for survival." The brain then prioritizes the substance above all else. That massive dopamine flood kickstarts the cycle of addiction. Memory centers log the experience with extreme bias. Motivation circuits get recalibrated to seek that high again and again and again. Your brain, built to keep you alive, now treats the substance like food when starving. This isn't a failure of character. It's a biological, predictable response to an overwhelming chemical signal. Why can one person drink socially their whole life, while another becomes dependent after just a few years? Well, a significant part of the answer is written in our genes, the cosmic instruction manual we inherit from our ancestors. Our DNA is the blueprint for building our entire body, including our brain. It determines everything from the color of our eyes to the specific structure and function of our neurons. Scientists now estimate that genetic factors account for about 40 to 60% of a person's vulnerability to addiction. This is not a destiny, but a predisposition. Think of it as a cosmic lottery. Some of us are born with genetic variations that make our brains react more intensely to addictive substances. For example, certain genes can affect how our bodies metabolize alcohol, making the experience more pleasurable and less likely to cause negative effects like nausea. Other genes might influence the number of dopamine receptors we have in our brains. If you have fewer receptors, you might get a less intense feeling of reward from everyday activities, making you more likely to seek out powerful artificial highs to feel that same level of pleasure. These genetic predispositions can be passed down through generations. If you have a parent who struggled with addiction, or a grandparent who struggled with addiction, your statistical risk of developing an addiction is higher. This is not your fault, nor was it theirs. It is simply a matter of the biological hand you were dealt. It's like being born with a predisposition for a certain type of cosmic weather. Some people are born with a higher chance of encountering asteroid storms. Knowing this can be empowering, as it allows for greater self-awareness and caution when navigating life's risks. It's crucial to remember that genes are not fate. Having a genetic vulnerability does not mean you are destined to become addicted. It simply means the threshold for developing an addiction may be lower for you. Your genes might load the gun, but it is often your environment and your choices that pull the trigger. This interplay between our innate biology and our lived experience is where the story of addiction truly unfolds. Our genetic blueprint provides the initial sketch, but the final masterpiece is colored in by the world around us. If our genes are the blueprint, then our environment is the master builder, shaping the final structure of our brain. Our experiences, especially during the critical developmental periods of childhood, adolescence, play a monumental role in determining our vulnerability to addiction. A child growing up in a stable, supportive, loving home learns healthy ways to cope with stress and regulate their emotions. Their brain develops strong, resilient neural pathways, creating a kind of psychological immune system. This safe and predictable universe helps them build a solid foundation for their future. Conversely, a child exposed to chronic stress, trauma, neglect faces a much different reality. Experiences like abuse, poverty, witnessing violence can flood a developing brain with stress hormones like cortisol. This constant state of high alert can alter the brain's architecture, weakening the prefrontal cortex, the center for decision-making and impulse control, while strengthening the more primitive, reactive parts of the brain, like the amygdala. This makes a person more impulsive and more likely to seek immediate relief from emotional pain, creating a fertile ground for addiction to take root. The social universe we inhabit also exerts a powerful gravitational pull. Peer pressure can be a significant factor, especially during adolescence when the brain is highly attuned to social acceptance. If substance use is normalized or even celebrated within a person's social circle, the barrier to trying it is significantly lowered. The availability of drugs or alcohol in one's community, school, home environment also plays a direct role. Easy access increases the likelihood of experimentation, which for a genetically vulnerable individual can be the first step on a perilous journey. Ultimately, addiction often begins as a form of self-medication. For someone grappling with undiagnosed anxiety, depression, the lingering effects of trauma, a substance or behavior can offer a temporary escape, a brief moment of quiet in a chaotic internal cosmos. The drug becomes a tool to numb the pain. The problem is that this solution is a mirage. Over time, it worsens the underlying issues and creates a new, even more powerful problem: the addiction itself. The environment has sculpted a brain that is both in pain and primed to seek a dangerous form of relief. The universe of addiction is vast and ever-expanding, stretching far beyond the familiar constellations of alcohol, opioids. In our modern digital age, a new galaxy of potential addictions has emerged: technology. Think of the endless scroll on a social media feed. Each new post, like notification, provides a small, unpredictable hit of dopamine, much like a slot machine. This creates a compulsion loop that can keep us glued to our screens for hours. Video games, with their elaborate reward schedules, level-ups, immersive worlds, are also designed to engage the brain's reward system deeply. For some, the escape into a virtual world becomes more compelling than reality itself. Shopping addiction, driven by the thrill of the purchase, workaholism, fueled by the rewards of success, validation, the pattern is the same. The behavior becomes the primary focus of a person's life, crowding out other interests, responsibilities, relationships. It is pursued compulsively, not for genuine enjoyment, but to satisfy an insatiable craving or to avoid the discomfort of not engaging in it. Understanding this broad spectrum helps us recognize that the potential for addiction lies not just in a bottle or a pill, but within the complex reward circuitry of our own brains. Addiction is not a static condition. It is a progressive one that physically changes the brain over time. The initial massive floods of dopamine begin to rewire the brain's fundamental circuitry. Your brain is a master of adaptation. Faced with this overwhelming dopamine signal, it tries to restore balance. It does this by reducing the number of dopamine receptors. It does this by producing less dopamine naturally. This process is called downregulation. First, the person develops a tolerance. The same amount no longer produces the same level of pleasure. They need more and more. The starburst of pleasure that once lit up their inner cosmos now feels like a dim flicker. Second, their ability to experience pleasure from everyday natural rewards is dramatically reduced. The world becomes a dull, gray place without the substance. The good news: the brain is plastic. It can change and heal. Recovery is rewiring the brain again. Through abstinence, therapy, support systems, medication, new, healthy neural pathways can be formed and strengthened. The prefrontal cortex can regain control. The brain's dopamine system can slowly recalibrate. It's a long, challenging journey, like a spaceship pulling out of a black hole, but it is possible. Understanding the science gives us a map for the journey, offering hope and a clear direction toward healing and a return to a balanced, stable orbit.